In keeping with our theme, envisioning the future of mathematics education in uncertain times, this evening we will hear from panelists throughout North America speaking on AI technology and its role in mathematics education. Our first speaker is Candace Walkington from Southern Methodist University, who will provide a review of the current literature on generative AI in mathematics education. Dr. Walkington is in the Annette and Harold Simmons Centennial Chair, professor in the Department of Teaching and Learning at Southern Methodist University, specializing in mathematics education. She was an IES postdoctoral fellow in mathematical thinking, learning, and instruction at the University of Wisconsin-Madison. Dr. Walkington was the recipient of a Spencer Postdoctoral Research Fellowship grant, and in 2019, she received the Presidential Early Career Award for Scientists and Engineers from the U.S. Department of Education. While at SMU, she has received a very impressive $12 million worth of grants as PI or co-PI from the National Science Foundation, from the U.S. Department of Education and the U.S. Department of Defense. Dr. Walkington serves as an executive editor of Cognition and Instruction. So welcome, Candace first. Thank you.
Hello, I'm Candace Walkington from Southern Methodist University, and I'm going to be talking about the implications of generative AI in mathematics education. Okay, so to start out, what is generative AI? So one of the most well-known applications in math education is having it solve math problems. So I gave it this problem that went viral on social media a year or two ago, and asked it to explain to me how to solve this problem. I used GPT-4, which is produced by OpenAI. And you can see it gave me a pretty detailed explanation of how to solve the problem. It gave me the correct answer. And it also was able to tell me why this might be a difficult problem, why this problem might have gone viral on social media. Now, if you look at output like this, you might get the impression that GPT is quite good at math. But a lot of the media coverage has talked about how large language models are bad at math. So where is the disconnect here? If we look at how contemporary AI performs on math assessments, the technology is actually quite good. It scores 89th percentile on the math SAT, 4 out of 5 on the AP Calculus exam, and 80th percentile on the quantitative GRE. So while generative AI is not a calculator, it's not a computer algebra system, it's not perfect, saying it's bad at math isn't entirely accurate anymore. Okay, so we kind of saw this one already, but I also asked an image generating AI to guess for me how y'all would look today. I wanted it to generate a picture of my audience at PMENA. So what do you think it thought y'all would look like? Let's find out. So first, let me say, y'all are really underdressed compared to this picture. I mean, you're also like sitting weirdly far apart, but more importantly, notice the striking lack of diversity in this picture. This is what it thinks our conference looks like. This is what it thinks our community looks like. And then notice who's in a position of power at this conference. This was the very first generation. I didn't even have to try to get it to generate this. We've got 5 white men in suits sitting at the front running things at this conference. So generative AI can not only generate text and generate images, it can also interpret images. This is something we've been looking at in one of our projects on students going on math walks in their community. So when they go on math walks, they take pictures around community spaces and they ask mathematical questions about those pictures. We've been experimenting with having generative AI be a thought partner for them in generating questions from pictures, especially at the beginning when they're just learning the process. So I gave ChatGPT this photo from the Martin Luther King Jr. Community Center, one of the sites we work with in Dallas, of this MLK mural, and asked it to come up with mathematical questions we could pose based on it. And as we found is typical, it actually did a good job of looking at the image and thinking about mathematical principles. It wants us to talk about patterns in the arrangement of the bricks, as well as what kinds of symmetry we could observe in the design. So our theme this year for the conference is envisioning the future of mathematics education in uncertain times. And the staggering capabilities of these AI systems has created uncertain times for our community. So to give a definition, generative AI is a class of AI that is capable of generating new data and outputs by learning patterns from training data. The rise of generative AI is happening in a context where we've seen significant changes in North America and the world, resulting from the pandemic, from war, from technological, political, and social shifts. And these shifts are also occurring within academia, reflected in theoretical and methodological change, and certainly methodological change is coming with the rise of Gen AI. And we have a history of considering our profession in the midst of these changes. So today, I'm going to talk both about the possibilities for generative AI and the ways in which it has created uncertain times for our profession. I'll be coming back to that over and over again. I'm going to talk about 4 areas. First, I'm going to talk about math problem solving, then math tutoring and feedback, then adapting tasks to learner needs with Gen AI, and then finally teacher planning using Gen AI. Then I'll close by talking about where we go from here. Okay, so I gave you some stats about how good Gen AI performs on our various assessments. But one thing I think is striking is how much it has improved. So the blue bars are the predecessor of our contemporary LLM GPT-4 called GPT 3.5. You can see it scored much lower on all of these assessments than the most recent model. One of the reasons is the most recent model has computer vision. It can actually read mathematical diagrams that are on the AP Calculus exam or on the SAT. And it's just getting better. So the new GPT-01 Strawberry model scored an 83% on the Math Olympiad qualifier, which requires complex and creative reasoning. So these problem-solving capabilities of generative AI have created uncertain times for lots of reasons. So there was a study that looked at the associations that generative AI made with the word mathematics. Remember, Gen AI is trained from training data of how humans feel about mathematics on the internet. So imagine what it's learning. And it in fact found that 10% of the associations GPT made with mathematics were negative words, like frustrating, anxiety, fearful. Now you might think this would be true for any difficult academic subject, but it was not the case for example, physics. This seems to be something unique to mathematics. And however much of a problem this is in GPT-4, GPT 3.5 was far worse. GPT 3.5 hated math. 50% negative associations. Imagine all the people that use this software and had these kinds of sentiments come from this AI. Research has also shown that AI is very sensitive to inconsequential aspects of how you prompt it. This was actually a research study where somebody told the AI they were a starship captain, and it got significantly better at math when it thought it was a starship captain. And Gen AI, despite its relatively impressive performance on assessments, it does make math mistakes. And it's unclear what the implications of making these mistakes are, especially when K-12 students see it make mistakes. It's also been argued that AI systems are fundamentally incapable of understanding people's embodied interactions in the world in ways that humans understand them. And Gen AI requires a lot of computing power. This can have financial and environmental impacts that disproportionately harm marginalized groups. And finally, there's a lot of concern over using Gen AI for cheating on assignments. While both the detection of Gen AI use and disciplinary action may differentially negatively impact special education students, English language learners, neurodivergent students, and Black students. There's studies coming out about this constantly now. So the second area that I'm going to talk about is Gen AI for math tutoring and feedback. So Gen AI can take student responses and attempt to diagnose errors and give pedagogical feedback. So I gave GPT-4 an incorrect student solution to x squared plus 6x equals 27. I took the incorrect solution straight from the IES practice guide for algebra, and I asked it to diagnose the mistake. It did a good job breaking down each step in solving the problem. It located where the mistake was, it said what the mistake was, and then it said the correct way to solve the problem. So some of the research is indicating now that Gen AI explanations and feedback can sometimes actually be preferred over educator-generated feedback because they're more thorough, detailed, and step-by-step. Now, an educator might just have written, "You forgot to include the negative root" as the feedback, whereas with Gen AI, we get this gigantic step-by-step explanation. But what are the implications of this for learning? Research is just starting to emerge on the effect of having generative AI tutor students on its own. This recent RCT by Bastani et al. Looked at 1,000 high school students. For 15% of their math curriculum for one semester, they used generative AI for assisted practice. There were 3 conditions in the study. One condition used ChatGPT. The second one used ChatGPT, but it was enhanced with solutions to their practice problems, as well as teacher feedback related to those solutions. And it also had instructions not to just give students the answers. And the final condition was a control condition, and it was a strong control, no devices at all in this condition. They looked at both their performance on the practice problem, where they had access to the resources, and their performance on a later exam. And what they found is that, not surprisingly, the chatbot tutors improved performance on the practice problems where it was being used compared to the control condition. But on the exam, ChatGPT was significantly harmful to students' performance. And the enhanced version of ChatGPT, there was no difference in students' performance. There was a slight negative trend for the enhanced version. So what the authors concluded is that GPT-4 alone was being used as a crutch. Students would ask it for the answer without much interaction or substance. And this lines up with other research that has suggested that using chatbots for tutoring can be associated with lower student confidence afterwards and no associated performance boost. Despite the lack of research on AI chatbots, the market for them is very quickly growing. The most popular one is Khan Academy's Khanmigo, which is a pay chatbot. You can see here, Khan Academy's Khanmigo can solve any math problem you want with it. Here I had it give me the problem 3x plus 2 when x equals 5. And one interesting thing about Khanmigo is that it remembers students' interests and can put any problem in the context of their interests. So I had told it I was interested in nursing, and you can see when asked, Khanmigo was able to change the problem and make it a problem about nursing. You can see Khanmigo has this little disclaimer up there that it does make math mistakes, kind of in small font. And just 1 year after launch, there were 65,000 students using it. They're expecting to expand to 500,000 to 1 million students for fall 2024. A lot of districts are using this as their approach to tutoring and licensing with Khanmigo. And Khanmigo, the reason it's so ahead of the game is that it came out very shortly after the release of ChatGPT. ChatGPT was released in November 2022. Conmigo in March 2023. A lot of the competitors were kind of trying to figure out how to do this ethically, but Conmigo went really quickly through that process. So Dan Mayer wrote a blog titled Conmigo Wants to Love Kids but Doesn't Know How. And this argued that these kinds of Gen AI tutors see mathematics as a numbered list of steps that a machine can execute one at a time. They see students as buggy computers whose errors should be identified and corrected. And the lie that Conmigo perpetuates is that math is about a huge number of small ideas. And this same critique could honestly be made about a lot of our digital learning platforms for math that don't use AI. But the rise of generative AI is making this problem even more important. And LLMs are certainly not perfect as tutors. They still struggle to understand incorrect student answers and the errors that lead to them, and they struggle to anticipate likely incorrect student answers. There's a lot of research on this specifically. The third area that I'm going to talk about is using Gen AI to adapt tasks to learners' needs. So Gen AI can be used to modify the readability of math tasks in curricula. Carnegie Learning has been doing a lot of work on this, and they found that Gen AI can, pretty similar to a human, successfully rewrite problems to enhance their readability, and this can improve mastery, especially for struggling readers. Gen AI could also be used in the future to generate diagrams that help learners visualize math problems. This is something my lab is really interested in. Imagine if for any mathematical task, you could click a Generate Diagram button, and it would give you a mathematically accurate and artistic rendering of what is going on in that problem instantly through Gen AI. Gen AI can also be used to adapt problems to learners' interests, like I showed in Conmigo. So we conducted a study of middle school girls using Gen AI to write personalized math problems for a video game they were pitching to a real video game company. And the girls found the math problems they could write with Gen AI to be fun and engaging. So let's listen to some of these girls right now talk about it.
And its effectiveness, AI can be used to make interesting, engaging problems very quickly. Like imagine you're a teacher, right? You're a math teacher. You're trying, and you already know your kids don't like math. No one wants to look at this boring problem on the board and solve it. So what you do, you go to chat. So what the teacher does, they go to chat GPT, they type in, okay, so here's this problem, now make it about wizards. Then boom, you got a problem about wizards that your kids are gonna love. And you did it in like less than 3 seconds. Come on, this is a win.
We've also been talking to teachers. I work with a lot of digital learning platforms that are interviewing teachers right now about their needs and wants for generative AI features. And many teachers that are interviewed show some enthusiasm about this use case for generative AI, using it to adapt to learners' interests. Here's 2 of those teachers talking about it.
I feel like this takes some strain away from the teachers because then instead of us having to, brainstorm different ideas of how to change the context of a problem, it's already there for us to expose our students to. So it would be good.
There's so much fear, and especially this group that I have, they, are willing to talk about something they're comfortable with and they feel like they have some knowledge that they could share. It's really intimidating whenever they have no clue. I mean, especially if they're already struggling in math and then they don't even understand the content or the subject matter that they're asked to talk about.
This use of Gen AI to adapt to learners has also created uncertain times. There are well-documented biases in generative AI against marginalized groups and preference for privileged groups, due in part to the nature of the Gen AI training data. We've seen this in our work too. And it also was evident in the picture that it generated of this conference. But this is an issue with generating text outputs as well as images. The images are very dramatic, but there's bias in the text as well. There's also privacy and surveillance concerns whenever we're collecting things about students in order to adapt instruction to them. So my final area I'm going to talk about is Gen AI to support teacher planning. And this is an area of interest because only about half of teachers' time is in direct interaction with students. And there's a lot of interest right now in finding ways to make that other half of their time better and more efficient. So one of the most popular tools for teachers that uses generative AI is Magic School. And Magic School can do it all. It can help teachers respond to emails. It can create assessment questions. It can create tasks that are relevant to their learners' needs. It can unpack the standards from them. This is just a few of the tools. There are dozens of Gen AI tools here that teachers can use. And Magic School advertises itself as a way to fight teacher burnout using artificial intelligence. There's been a lot of research emerging on this more than any of the other areas in the math ed proper field. And there's been some promising results for using Gen AI to build mathematical and pedagogical knowledge for teachers, to simulate students, and to help teachers plan lessons. Generative AI can also classify teacher moves from rehearsal transcripts to give math teachers actionable feedback. Research shows that teachers often extensively modify Gen AI output to suit their needs and context, and that teachers are not yet fluent with prompting for follow-up requests from the Gen AI. They kind of get the output and either keep it or don't keep it. We did a study of math teachers using Magic School for lesson planning, and the teachers recognized some affordances. Here's a short video.
Wow. Technologies. We're not going to need teachers anymore. Like, they don't realize that business hours are like, oh my gosh.
Oh, I did.
That's great.
So it just gave us a little mini lesson on it. And then we also use it for the standard unpacker as well.
Okay.
And it took me seconds to do it. And this is something that normally would take me a good hour.
So these tools have also created uncertain times. Research has shown that they can create developmentally inappropriate content, like a scenario about weight loss for middle school students. They also have difficulty in adapting tasks meaningfully to different kinds of learners or different learner interests. They can do it on a surface level. So here are some of my teachers talking about adapting to emerging bilinguals.
For the main development, we did a student who was ESL from another country. It really didn't change anything. Like, now that I look at it, the words are pretty complex. I'm ESL, and I feel like these are not adapted to ESL and thank you.
And the teachers note similar things when trying to use it to adapt to students' interests. Here are some teachers talking about using it to adapt their problems to be about their students' interest in Taylor Swift.
But it was about laptops and keyboards. So we will be make it relatable to Taylor Swift, or make it relatable to buggies. And it would just be, Taylor Swift wants to buy laptops. No, that's not what we want.
Okay, so I've talked about 4 different areas of research in generative AI. So I'm going to close by talking about where we go from here. And I'll start with the observation that Gen AI has not had a transformative effect on mathematics education so far. And there's probably various reasons why this has happened. If you ask teachers why they're not using generative AI, the #1 response is, I have other priorities that are more important. And I think this is a really telling result. I work with a lot of these digital learning platforms that are interviewing teachers right now about their needs for generative AI so that they can create products that teachers will like and use. And normally the teachers are pretty polite about it. They'll kind of go along and give their feedback. But every once in a while, one of them will kind of break the script and tell us what they really think of us focusing on generative AI in the midst of everything they're facing. So here is one of those teachers, an Algebra 1 teacher.
Yeah, do you think having a feature that sort of customized the context to something they had knowledge of would address that issue?
It could help, anything is better than nothing, but that's not the issue. The issue is the gaps of what they do and what they don't know based on where they are. Because teachers have a problem, and this is a teacher concern. We're trying to fill gaps. Like the city does potholes. You know what I mean? If you ever seen the cities do potholes, man, they just put something over it But if the car hit that hole, you know, maybe 20, 30 minutes later, the pothole gonna be right back there next month.
Yeah.
Instead of tearing up the street and starting over.
Yeah.
And unfortunately, that's kind of what we're trying to do. And so.
And then here's a video of a 6th grade mathematics teacher. We were talking about magic school to make tasks relevant, and it went a little off task.
It's so hard to feel like coming in, the teaching philosophy was, oh, well, I'm going to make sure my kids are like well-rounded and they're like critical thinkers. And now since like the district is like, why are your test scores so bad? Why are your test scores so bad? Why are your test scores so bad? It's like, okay, my curriculum is going to be test questions, basically. So I have that.
Mathematics teachers have real problems, and they're problems that they know AI is not going to be able to solve. Advances in generative AI and the influx of funding and work around it can actually serve as a distraction from these real problems teachers face. This has led people to ask, is Gen AI a solution in search of a problem? Many current Gen AI applications in our field only apply well to repetitive skill practice where students are individually at a screen. And millions of dollars are being spent to make this one part of math instruction slightly more effective. In addition, Gen AI is being rapidly scaled even though we are just beginning to understand its ethical issues and potential negative impacts on learners. So for my last 1 minute, some recommendations. Gen AI tutoring in under-resourced settings with diverse languages spoken is important. Its translation abilities have the potential to open up access. Partnering human math tutors with Gen AI supports can allow the tutors to better focus on math understanding. RCT about this just came out a few days ago. That was really promising. Gen AI could also help with some issues that marginalized learners face during traditional instruction, like readability issues. We can't ignore these kinds of effects. But longer term, partnering students with Gen AI to confront rich and complex tasks has promise. There's been research on partnering students with AI to confront math modeling tasks, telling math stories, constructing proofs, and the place-based noticing and wondering I talked about at the beginning. Gen AI may eventually become a strong lesson planning partner, but for the moment, it's reasonably good at building basic teacher knowledge and generating some possible student responses. And to close, the NCTM position statement on generative AI that came out in February, it hoped that generative AI could shift students' thinking from solving to a mix of solving and verifying to create positive pressure to create assignments and assessments that blend the fundamentals and creative thinking. And the teachers would be able to develop batteries of math problems tailored to students' lived experiences. This largely hasn't happened. The focus for Gen AI has been something else. And our community needs to create positive pressure for funders and curriculum developers to pursue these kinds of goals and address the real pressing problems teachers face, in addition to the skill practice-based Gen AI applications currently being emphasized. And there are many ethical issues and unintended consequences when implementing Gen AI, and we need to improve education on these issues at all levels. And I'd like to thank my funders, the Bill and Melinda Gates Foundation and the National Science Foundation, and the QR code is to my paper. Thank you.